Hey guys, welcome back. I'm going to cover the last topic of this section, branching statements. Branching statements allow us to redirect the flow of program execution. There are three branching statements in Java: break, continue, and return. In this lecture, I will cover break statement, continue, and return will be covered in next lecture. The break statement is used to break out of the looping statement and switch case block. Hope you guys remember the use of break statement in switch case block and how removing the break statement created fall through. In this switch case example, color code is capital G. At runtime, matching case is found and control enters this matching case. But there is no statement and no break, hence fall through starts. It executes the next statement in the sequence, which prints green onto the console. Then Java runtime encounters break. This break statement takes the control out of the switch case block. In the case of for loop, when Java runtime encounters a break statement, it skips the remaining statement and takes the control out of the for loop. Break statement has the similar behavior with while and do while loops as well. It skips the remaining statement and takes the control out of the loop. In the case of do while as well. Let's start with a very simple example. In this example, this loop prints number starting from 1 till 100,000. Run the program to verify the output. Last number printed onto the console is 100,000. Let us scroll up. But the first line in the console shows 88,572. But we expected our output to start with 1. Actually, output started with 1, but console window has some fixed size. If console used all of the assigned space and it has to print more data, then it starts deleting the printed data from start. And that is why initial output is missing in this case. If you want to see all the data in the output, then you need to increase the size of the console. To do that, right click inside console view, click preferences. Currently the console buffer size is set to 80,000 characters. Add one more zero to increase it to 800,000 characters. Click on apply and then OK. Run the program again. The last line still shows 100,000. Let us scroll up and now we see output starting with 1 and continuing till 100,000. Now let us consider a scenario in which upper bound will be provided at runtime. To provide an upper bound, let us create an integer variable int upper bound, initialize it to 20. You have to execute the loop till upper bound, which is 20 in this case. But you are not allowed to make changes in the initialization expression, boolean expression or step expression. How would you stop this loop when it had printed numbers till 20, which is still upper bound? In this scenario, break statement comes to our rescue. I want to exit this loop when value of I is equals to upper bound. Let's convert this in logic. If I double equals upper bound, then break. Save the file. During the loop's execution, when value of I becomes 20, this boolean expression returns true and Java runtime executes this break statement. Break statement takes the control out of the for loop after printing numbers from 1 to 20. Let us verify the output. Output is numbers from 1 to 20. Let me change the upper bound to 100 and verify. Save it. Run the file. This time output is from number 1 to 100. Over here, break statement causes the loop to terminate early. Let us see another example on break. In this example, we have nested loops. Outer loop represents rows or number of lines in the output. Variable row starts with 1 and goes on till 100. So there will be total 100 rows in the output. It is labeled as outer. Inner loop represents the number of columns in each row. Variable COL starts with 1 and ends at 10. there will be total 10 columns available at each row. Inner for loop is labeled as inner. Let me run and check the output. Copy this output first, Control C, and paste it in Notepad++. If you look at the output carefully, each row is a table of a number. First row is table of 1, second row is table of 2, third row is table of 3, and so on. The logic I wrote prints the table of 1 first, then it goes and prints the table of 2, which is first finished row 1, then row 2, and so on. If you are confused with the output, then use pen and paper and draw the memory states to understand what happens at runtime. Just do it for 2 rows to understand. It's really simple. It's a 2-dimensional problem which we had already seen in nested and labeled statements lecture. Now instead of printing the whole output onto the console, I want to stop the loop once a particular number is hit for the first time. For example, let me select any number, say 24. This is a really nice feature of Notepad++. It colors all the matching data. So number 24 appears 6 times in the output. In this case, I would like to print the output till here, which is I would like to print these numbers onto the console. And which means come out of the loop after printing this number onto the console, which is don't print rest of the output onto the console. Let's implement this logic. Add a variable to store the number at which we would like to stop the loop or come out of the loop. Int stop at, initialize it to 24. Now add the logic to break out of the loop. So after we had printed the number, let's have a check for a stop at. If number double equals to stop at, break, save it. This should work. Let's check. Run the program. It seems our logic is not working. Copy the output and paste it in Notepad++ to analyze. Control A, Control C. Open another tab in Notepad++. Control V. My intention was to stop here, which is don't print more rows to the output. But looping logic did not stop printing more rows at 24, but it had not printed columns after 24. So there is no data in this row after 24, no data in this row as well, and so on. This clearly means break statement broke out of the inner loop, which prints columns, because outer loop prints rows and inner loop prints columns. So our break statement broke out of the inner loop. Over here, when Java runtime hits first 24, we have a break statement, and this statement takes the control out of the inner loop. The Java runtime executes blank system.out.println statement, which moves the cursor to the next line. So it places the cursor over here, and the outer loop continues, which starts printing a new row to the console. Break statement used without any label takes you out of the innermost loop. And yes, we can use labels with break to instruct which loop to exit. In this example, break without any label is similar to break with innermost loops label, which is inner in this case. Save the file. If I run the program again, I will get the same output. The program did not stop printing rows after it printed first 24. Let's break out of the outer loop now. Save the file, run the program, and this time we see the expected output. After printing 24 for the first time, Java runtime executes break outer, which takes the control out of the outer for loop. No statements to execute after that. Main method ends and the program terminates successfully. In this example, we had seen that labeled statement with break can easily solve some of the tricky problems. With this, we have come to an end. I will cover continue and return statements in next lecture. See you there.